class. In this session we are going to continue with the exercise 19.1, which we had discussed in the last class, how to derivate the exponential function, and we have attempted questions from the exercise 19.1, and in today's session we are going to continue from question number 13. It says that find the equation of tangent to the curve y is equals to 2e to the power 3x at the point where x is equals to 1. Find also the equation of normal to the curve at this point. Alright, so there are two parts in this question. At first I will talk about the first part, that is from the beginning till the point x is equals to 1. It says you need to find out the equation of line. So the working formula we have to find out the equation is y minus y1 is equals to m, and it's x minus x1, right? That is the working formula to find out the equation of line. We need to find out the value of gradient first, and we know that gradient is what? It's dy over dx, right? And we have the value of x we need to find out at x equals to 1. So that's how we can find out the value of gradient. For x1 and y1, the value of x1 is equals to 1, that is given in the question. Here it is, right? We have the equation y is equals to 2e to the power 3x. You need to place the value of x is equals to 1 here, and you will get y1 here. Alright, so I have discussed the whole working how we are going to attempt this question. So first you need to give it a try, and then I will explain you the correct answer. So you have a time of 2.5 minutes. Alright, 2.5 minutes to attempt this part, and then I will explain. So start. At first I will start with the differentiation. To derivate dy over dx, it will be equals to 2. The derivative of exponential is exponential, and then the differentiation of its power, so it will be 3. I can say that it's 6e to the power 3x. That is dy over dx. We need to find dy over dx at x is equals to 1. So that is equals to 6e to the power 3, and x is 1. So I can say that it's 6e to the power 3. That is my dy by dx, right? We have the value of x1, that is equals to 1, that is given. But for y1, we need to place the value of x in the equation y equals to 2e to the power 3x. So when x is 1, so y is equals to 2e to the power 3. Alright, now we need to apply the correct working formula. Y minus y1 is equals to m x minus x1. Alright, so now it will be y minus y1 is what? y1 is 2e to the power 3 is equals to m is what? 6e to the power 3. X minus x1 is what? x1 is 1. Alright, so far so good. Is it clear to you, all of you? After that we can multiply on the right side, so that will be 6e to the power 3x minus 6e to the power 3. When this 2e power 3 shift on the right side, it will be plus 2e to the power 3, and on the left side we have y only. And now it is equals to y is equals to 6e to the power 3x minus plus minus is 4e to the power 3. And after that we can take common here, so the common we have it's 2e to the power 3, and inside the bracket it will be 3x minus 2. That is the equation of tangent that we are looking for, and that is our first part answer. Alright, I hope that it is clear to you and there is no problem in this part. After that, the second one, it says find also the equation of normal, right? So firstly, what is the difference between the equation of tangent and normal? So we need to apply the condition of gradient, which says that m1 times m2 equals to minus 1, right? The value of m1 we have, that is 6e to the power 3, right? This is the value of m1 times m2 is what we are looking for, is equals to minus 1. So m2 is equals to minus 1 divided by 6e to the power 3. Now we need to apply the working for equation of normal. So it's y minus y1 is equals to m x minus x1. You have the values of x and y. What you need to do first, note down the solution and then give it a try by yourself. And for this part you have a time of 90 seconds to start, so begin. So now it will be y minus value of y1 which we had find out is 2 e to the power 3 is equals to m is what? It's minus 1 upon 6 e to the power 3 and it's x minus x1. If we multiply on the right side as we had done in the previous part, so now it will be equals to y minus 2 e to the power 3 is equals to minus x over 6 e to the power 3 minus minus plus x1 is what? X1 is 1 which we had find in the previous question as given in the question as well. So it's 1 over 6 e power 3. Alright. Now if you shift minus 2e on the right side, so it will be equals to minus x over 6 e to the power 3 plus 1 over 6 e to the power 3 and plus 2 e to the power 3. That is your equation of normal. Alright, that is the equation of normal, and this one is the equation of tangent. So it is quite similar to coordinate geometry. The thing that differs here is how you are going to find out the gradient, that is the differentiated part only. Rest, the equation y minus y1, we all know very well how to solve this equation. Alright, so that is your question number 13. And after question number 13, moving on towards the next question, it's question number 15. Yes. The question says the curves y is equals to e to the power 2x minus 3 and y equals to e to the power a minus x meet at P where x is equals to 2. Find the value of a. So firstly, I have two equations of curve. The first one is y is equals to e to the power 2x minus 3 and the next one is y is equals to e to the power a minus x. We have the value of x and that is equals to 2. So if I place the value of x2 in both of the equation, I get y is equals to e to the power 2, x is 2 minus 3. So that will be equals to y equals to e to the power 4 minus 3. Sorry, 4 minus 3. And y equals to 4 minus 3 leads to e to the power 1. On the right side of the equation, it is equals to y is equals to e to the power a and x is what? 2. Alright. If you observe that on both sides of the equation we have y and y, so I can equate the value of y in these two cases. So I can say that it will be e to the power 1 equals to e to the power a minus 2. Now we got same basis and that is e, right? And then we have same basis, we can equate the powers. So I can write in this form 1 is equals to a minus 2, which implies that a is equals to 1 plus 2 is equals to 3. Alright, so first we need to note down the solution till here, and for that part you have a time of 90 seconds to note down the solution till here, and then we will start with the part B. So start. Alright, so in part B it says you need to find out the gradient of each curve at P. So let me first tell you how to find the gradient of the curve. We have the equation y is equals to e to the power 2x minus 3. For gradient we need to derivate the function, so now it will be dy over dx is equals to the derivative of exponential is exponential, that will be e to the power 2x minus 3, and now the derivative of the power is 2. So I got the derivative is 2e 2x minus 3, that is dy by dx. We have the value of x and that is equals to 2. So dy over dx at x is equals to 2 is equals to 2 e to the power 2, the value of x is 2 and minus 3. So it will be equals to 2 e to the power 4 minus 3. And further you can say that it is equals to 2 e to the power 1, that is your gradient of the first curve. Alright, for the next part, for the next curve, when you have the equation y is equals to e to the power a minus x. First give it a try by yourself, find out the gradient, you have the value of x, and then I will explain, and for that part you have a time of 60 seconds to start. So start. Now dy over dx is equals to, the value of a is known now, and that value is we have it's 3, so now it will be 3 minus x. So the derivative of e is e to the power 3 minus x, and the derivative of power it's minus 1. Now I will place the value of x here. So at x is equals to 2, it is equals to e to the power 3 minus 2, and we have minus 1 as it is. So now it will be minus e to the power 1, that is your dy over dx. Alright, so I hope that you are getting the same answer. Not a difficult part, and easy part it is. We know how to derivate the exponential, and we know very well how to find the dy by dx when the value of x is given, and we have applied the same things in this question. After that, moving on to the next question, that is question number 16 from the same exercise 19.1, and in this question it asks about approximate change, which we had discussed already in chapter number 16. It says that given that y is equals to e to the power minus 2x divided by 6, find dy by dx. Alright, that is your first part, to find out the derivative of x. And for differentiation part, you have a time of 60 seconds. So start. Alright, so now it will be, when you find out the derivative, it will be dy over dx is equals to 1 over 6 as it is. The derivative of exponential is exponential, and now we need to find out the derivative of its power, so that will be minus 2. So we can say that 2 1s, 2 3s are 6, so it will be minus e to the power minus 2x divided by 3, that is your dy over dx. Alright, after that it says, hence find in terms of p the approximate change in y when x increases from 1 to 1 plus p, where p is small. So in case if you forgot the working formula, it says that small change in y divided by small change in x is equals to dy over dx, right? And for dy by dx, we need to find the initial value of x, and the initial value of x is 1, right? So why don't you give it a try by yourself, and then I will explain, because we had done the approximate change subtopic in previous exercise. So give it a try. You have a time of 90 seconds, and then I will explain. So start. So firstly, I will find dy by dx at the value of x. So dy by dx at x is equals to 1 is equals to minus e minus 2 divided by 3. That is my dy by over dx. We need to find out a small change in y, right? And the change in x from 1 to 1 plus p. So change in x is p is equals to dy by dx. We have its minus e minus 2 divided by 3. Alright, now we simply need to find out delta y, and for that part it's minus e minus 2 divided by 3, and this p, when you shift on the right side, it will be multiplied with this expression, and that is your delta y answer. Alright, so after question number 16, moving on to the next one, it's question number 17. It says the area of a region a centimeter square after t seconds is given by area is equals to, I'm going to write the equation here, area is equals to 12 minus 8 e to the power minus t upon 2, where t is greater than 0. Find in terms of e. So we cannot solve the value of e here. The first part, the area of the region when t is equals to 2. Alright, so that is very easy question. What you need to do, you need to place the value of t is equals to 2 in this equation, and I'm going to do the same here. So the expression is area is equals to 12 minus 8 e to the power, it says minus t upon 2, the value of t is 2, so now it will be minus 2 over 2, right? I have placed the value of t, and it is equals to 2 here. Now we need to solve it. So area is equals to 12 minus 8 e to the power minus 1, and it will be 12 minus 8 divided by e, changes the sign of power, and after taking LCM it will be 12e minus 8. Alright, so that is your area when the value of t is 2, and we are going to leave our answer in terms of e. So that is my first part answer. Alright, so that is your first part, and what you need to do, first write down the solution, and you have a time of 50 seconds, I think, quite enough to note down in your copy. And after that, in part B, it says the rate of change of a when t is equals to 2. So you need to derivate the function, right, and place the value of t equals to 2, and then solve it, and then I will start the correct solution. So now you have a time of 2.5 minutes for part B. So start. I hope that you had done it, and now see your answer. So the expression of area is 12 minus 8 e to the power minus t over 2, right? If we are going to start the differentiation, so dA over dt equals to, the derivative of 12 is 0 because that is a constant, so it's 0 minus 8. If I am going to start differentiation e, first thing, that the differentiation of exponential is the same, and now we need to derivate the power. So the differentiation of power minus t upon 2, it will be minus 1 over 2. Alright, that is your differentiation for exponential. We have the value of t here, so I'm going to place the value. So now it will be minus 8 e. The value of t we have, it's minus 2, so it's minus 2 over 2 times minus 1 over 2. I can simplify here. 2 1s are 2, 2 4s are 8, minus minus plus, so it will be positive 4. For e, it's e to the power minus 1. Alright, and after that we have negative power of e, so I can say that it is equals to 4 divided by, when you shift e in the denominator, it changes its sign, so that is your dy over dx at t is equals to 2, and it's 4 upon e. Give your answer in terms of e as it is stated in the question. Alright, so that is your second part. I hope that you are getting the same answer. And after that, in the last part, it says find the percentage change in a when t changes from 2 to 2.1. Alright, so firstly we need to find out the small change. So I can say that the working formula, it will be change in a, small change, divided by small change in t is equals to dA over dt. Alright, that will be the working formula. We need to find out the small change, and the value of t changes from 2 to 2.1, right? It means that the initial value is 2, and we had already find out the rate at t equals to 2. So dA over dt, we have it's 4 divided by e, as we had find out in the last part. The change is from 2 to 2.1, the change is 0.1, so delta A divided by change is 0.1. Alright, so you can say that delta A is equals to 4 divided by e times 0.1. It leads to 0.4 divided by e, that is your small change in area. We have the value of change in area, right? To find out the percentage change, the working formula we have is change in area divided by initial value of area times 100. That is the working formula, right? Change in area we have, it's 0.4 divided by e divided by original value of area we had find in the first part, it's 12 e minus 8 divided by e and times 100. Now we can simplify it, so e and e cancels, right? So it will be equals to, when 0.4 times 100, it will be 40 divided by 12 e minus 8. You can find out the value, so it will be e into 12 minus 8, it is equals to 24.62. So 40 divided by 24.62, it's equals to 1.62 percentage, and that is your answer. Alright, now you need to note down the solution in your copy, and for that part I'm giving you time of 60 seconds to note down the solution, and then we will start the next one. Alright, after that we have question number 18. It says variable x and y are connected by the equation y is equals to 5e to the power minus 3x. Given that x is increasing at the rate of 0.1 units per second. So what it is given? It is change in x with respect to time 0.1 units per second. Find the rate of change of y. What is unknown? Unknown is dy over dt. When x is 0.5, give your answer correct to 2 decimal places. So that is question from the topic chain rule, which we had discussed in chapter number 16. Alright. So first give it a try by yourself, and you have a time of 2 minutes 120 seconds to give it a try, and then I will explain. So start. The first and the important thing, we need to write down the working formula of chain rule. So that will be dy over dt is equals to dy over dx times dx over dt. That is my main working formula. I need to find dy by dx first. So we have y is equals to 5e to the power minus 3x. When I derivate it, it will be dy over dx is equals to 5. The derivative of exponential is 5, and now the differentiation of its power. So now it's minus 15e to the power minus 3x, right? And we have the value of x, it's 0.5, so it's minus 15 e 3 and x is 0.5. And we can find out the value of e to the power 3.5. So 3 into 0.5, it will be 1.5 power e. It's 4.48 times 15, so it's 67.2. Alright, so that is my dy over dx. So I got the value of dy over dx, it's minus 67.2. Alright, the value of dx over dt, it's given, that is 0.1. So when you multiply it, you will get 6.7. Alright, and there is one slightly mistake that I have made here, not in this part, but here the power of e is minus 3. Alright, so when I find out the value now, so now it will be 3 into 0.5 with a negative sign e to the power, so that is 0.223 times 15, so that is equals to minus 3.34. that is your dy by dx. Alright, now we are going to place the value here, so it's minus 3.34. The value of dx over dt, it's dx over dt, it's 0.1. So we need to multiply it by 0.1. So that gives you the value of minus 0.33. That is your dy over dt. Alright, so that is your answer. Make sure that you are not going to make any mistakes regarding the sign. So take a close look at it. Alright, so I think that it is quite enough for today class. Inshallah, in next class we are going to start with 19.2, and make sure that you practice exponential differentiation very well, and try to attempt all those questions by yourself which we had discussed during the class. And whenever I am giving you time to try the question, so give it a try. It does not matter that you are doing it wrong. The thing that matters the most is that